Okay, today we're going to look at section 4.4. We've been doing some work in the last few sections proving triangles are congruent by different theorems. And so now, once we know that triangles are congruent, we can make conclusions about their other corresponding parts, because by definition, if two figures are congruent, then their corresponding parts have to also be congruent. And so in this section, we're going to be doing some proofs where we show that the triangles are congruent, and then we go one step further to say that two of their corresponding parts are congruent. And we use this CPC-TC. This is just an abbreviation of the corresponding parts of congruent triangles are congruent. And so this is much easier to write down. That's what we're going to use as an abbreviation. Okay, so let's look at example 1. Here we have an umbrella frame, and we're not looking at the top part of the umbrella, just the bottom frame part. And so whenever these stretchers get opened up, then they have angles of equal measure. So we're looking at what we're given. We're given that SL and SR are congruent. Those are sides. And we're given that angle 1 is congruent to angle 2. I'm trying to prove that angle 3 is congruent to angle 4. Just trying to go straight to that, I don't have enough information. But if I can prove that the triangles SLC and SRC are congruent, then I could say that angle 3 and angle 4 were congruent because they're corresponding parts of those two congruent triangles. So let's start with the first statement, which would always be the given statement. Okay. You should never miss that part on the test. Always write down the given information. My phone's restarting. Okay, and so the next thing that I want to do, so my plan is to first show that the two triangles are congruent, and then we can use that CPC-TC to show that the angle 3 is congruent to angle 4. So we've had several methods for proving triangles are congruent. We've done side, 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 angle, 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 side. So I'm going to look and let's figure out which one might be the easiest one to use. So we have this side is congruent to this side, and we have the angles 1 and 2 are congruent. Anytime two triangles share a common side, that's the easiest thing to get because we can use a reflexive property. So I'm going to just write down that SC is congruent to SC. By the reflexive property. One of the parts of proofs that are sometimes hard is trying to figure out, once you get out of each section where you knew how you were trying to prove they were congruent, trying to figure out which theorem you're going to use. So I'm looking for the things that are easy to show are congruent. And this time it was the common side that they shared. So what I have is a side, an included angle, and another side. So I can say that those two triangles are congruent by the side angle side theorem. Okay, so let's see, that's going to be triangle SLC is congruent to triangle SRC. Okay, now once we have this, we have one more step that we want to do because we want to say what we're trying to prove, that angle 3 is congruent to angle 4, which we can do by the CPC-TC. Okay, so I want y'all to try quick check 1. So you need to pause it and see if you can figure out. Maybe before you pause it, let's look at a plan. So here we have a figure, a quadrilateral that's broken into two triangles. We're given that angle Q and angle R are congruent. I've marked those with one arc. Angle QPS, which is the one here, is congruent to angle RSP. Alright, so we're given two angles, and we're trying to prove that SQ is congruent to PR. So that's over here, this side, and this side. Okay, so the plan would be to try to prove the triangles PRS and SQP are congruent. Now notice when I'm writing this down, I'm trying to make sure that my corresponding parts, the letters are lined up for those. So you're going to try to prove that, and then you're going to be able to say your proof statement, the two sides are congruent by the corresponding parts of congruent triangles. So pause and see if you can get to the point of at least having the triangles congruent. Okay. So hopefully you tried this and were successful. I'm going to write down my given information. Angle Q is congruent to angle R, and angle QPS is congruent to angle RSP. And that'll just be given. Okay, so you have two angles. Again, these two triangles have a common side. That's always the easiest thing to get, so I'm going to write that down. PS is congruent to PS. And that's just by the reflexive property. Okay, so we have enough now to say the two triangles are congruent. This time we have two angles and a non-included side, so we're going to be using angle-angle side. You might hear some background noise. Just ignore it. There are people walking through. Once we get these two triangles congruent, now we can list our proof statement, because side SQ and side PR are corresponding parts of the triangles that we now know are congruent. So that's going to be our CPCTC. It's kind of hard to remember the order of the letters, but just remember the C's go every other one. Okay, on the last example, I tried to at least draw sort of the picture that was in the book. They were talking about Napoleon's officers and how they tried to estimate the width of the river. So they just said that the officer stood up straight and lowered his visor of his cap until he could see the farthest thing on the edge of the opposite bank. And then he turned, and so he was looking across doing that, and then he turned and looked the other way to see the farthest thing. And then he paced off the distance from E to G, and he could figure out how far it was across the river. So we're going to look at why that worked for him. So we're given that angle DEG and DEF are right angles. That's here. So let's go ahead and write that down. We're also given that angle EDG is congruent to angle EDF. All right. So let's look at where those are. Let me change to purple. All right, so angle EDG is at the top, and angle EDF is also at the top in the other triangle. So we have two right angles, we have the top, and then can you guess that we might use that shared side to get another part of the triangle? So first of all, though, remember that we can't take for granted that people know right angles are congruent. We need to write that step out. So I need to say angle DEG is congruent to angle DEF. We have to say that these are congruent. That's part of our proof. So the reason would just be that all right angles are congruent. All right, so now we have two angles that are congruent. Let's do that in that side DE. So DE is congruent to itself by the reflexive property. So while proofs are kind of difficult to get used to, you will find that you keep doing the same type things over and over. We've used the reflexive property a lot. So that's always something to look for. Now we can make our triangle congruent statement because we have two angles and this time an included side. So our reasoning will be angle side angle. So I'm going to have triangle DEF is congruent to triangle DEG. Now that's not the end of our proof. That's what we've been ending there, but now we're trying to prove that EF is congruent to EG. Those two sides are corresponding parts of these congruent triangles that we just wrote down. So now I can say that EF is congruent to EG using the corresponding parts of congruent triangles, or congruent. Okay, just quickly looking at Quick Check 2, this was an extra question that wasn't a proof. So because they were talking about the officers pacing off the distance using his steps from E to G, they said about how wide was the river if the officer stepped off 20 paces and each pace was about 2.5 feet long. So how would you figure that out? So he took 20 steps from E to G, and he's estimating that E to F is the same. So for each step that he took, it was 2.5 feet long. So I would just multiply the 20 times the 2.5. And it's going to end up being 50 feet. So it was about 50 feet from where he started to where he stopped at G. Okay, let me know if you have any questions. See you in class.